Okay, so this is going to be an introduction into assembly programming. This will be a simple example that is meant to accompany Lab 1.0. You should be watching this before Lab 1.0 or if you get stuck during the lab. So this semester, what we'll be using is an online compiler, and the link for this it will be posted for this week's content, but it's real simple. The link is just demo.yasp.me. And so this will come up, and the great thing about this is that you don't have to install any software. And so it saves a lot of space on your computer for one, because some of these compiler software installs can be massive. And I know that causes issues, especially when you're taking this class online, if you don't have access to the university's computers and resources. So with that in mind, I've switched to an online format, at least for this portion, to program in assembly. So you'll just want to navigate to this link, and this is the default page that comes up. We'll even do a quick refresh for you. So you can see this is just the example code that they have in. And the really cool thing about this, let me switch to debug for just a second, is that they're displaying essentially a virtual microcontroller. So when we have labs, any of our assembly programming labs that involve lighting up LEDs, you can see them down here and their pin numbers. Um, this helps. Oh, we have 1, 2, and then all of these LEDs. So we've got push buttons, LEDs. We won't necessarily use all those in assembly programming, but these resources are here. That way you don't have to plug in a physical board yet for this portion of the course. So before I plug in my code, I want to go over a couple things on this main page. So we have a few buttons in the top left here. The first one is the run button. So this runs your code from start to finish. I do not recommend that. What I suggest is using this little bug. It represents debugging. And this will allow you to step through your code one at a time. It'll let you know if there's any errors. This is really just the way to go. And then we have an information button, and if you need to upload a program that you've already saved, you can do that as well. Over here in the file menu, we also have new options, save options, and then we can find, if you have hundreds and hundreds of lines of code, you can search for lines, replace lines, and so on. We really won't be using this portion unless you want to, but it's really not necessary for the simple codes that we'll be doing. What I would recommend is taking a look at the tutorial over here, and this just outlines the capabilities essentially of this assembler. It tells you a little bit about it, a little bit about the syntax, which is important. Remember, that's kind of like the country, it's the modifier of our assembly program. So we're using assembly language, but some of those pieces might be a little bit different. And I've tried to address all of those differences in the lecture for this week. But if you see something unusual, or if maybe you get into this deeper on your own, you explore different commands, this tutorial is a really good overview about how to set some of those up. It's also important to note right here, these features, we have 32 byte registers. So we have 32 registers that can hold a byte of data, and those are labeled B0 through B31. So if you've watched the lecture for this week already, you've seen a couple examples where I've used these B registers. It also talks about the I/O pins, which we really won't be using. It does have a carry and 0 flag, which we will need to pay attention to. And then it gives you the basics of the commands. So if you feel like maybe they're still a little foggy after the lecture, of course you can ask me about them, but this is another way of explaining them too, and another good reference for you to come back to as you're programming. It's right here. So that's the tutorial. Okay, now I'm going to go ahead and get rid of this default code, and I'm just going to paste in my example code here. So let me go over this. The first line, of course, we always start our program with underscore main and a colon, right? That's absolutely necessary. And then we see on the next line, And what I love about this assembler too is down here, it gives you an explanation. So it's explaining the move command to us as a refresher. So it's telling us that we have a literal number, you can see it 250, that we are putting into the register. And so that's reflected down here in the syntax, and then it's giving you a quick little snippet. So this first line here, I'm just inserting the value 250 into register 1, which of course is labeled B1. And I do ask that when you're programming in assembly, in C, really in any language, you should always add comments on every line of code. I talked about this in my lecture, how important these are. These are a good refresher to yourself if you've left the code for a while and you've come back to it, or if somebody else has to work on your code, or if your instructor has to grade your code. This helps me figure out your thought process and what you were thinking with a line. So always include comments wherever you can. And I like to include them here, of course, because it makes it easier for you to see what's going on. This is probably your first time with assembly code, and so it's easier for you to read through my comments and see exactly what each line is doing. And then, of course, this explanation at the bottom is also great. Okay, on to the second line. So I've loaded the value 250 into register 1. Now I'm just going to transfer that value into register 3. We're just moving it over. And then I'm going to move the value of 10 into register 2. Now I could switch these lines around. They don't have to be in this particular order right now. I'm just putting things in different places. So I could switch up the order if I wanted to. I'll put them back how they were though. So I'm just moving things around into different registers, getting them all set up. And then we come down here to line 5. And in line 5, I'm adding the contents of register 3, which remember, we moved that 250 into there indirectly. It went into register 1 and then copied over to 3. So we're adding the contents of register 3, put 250 in parentheses here, even in my comments, to the contents of register 2, which should be 10. So of course the result of these will be 260, and it's going to move those into register 2, right? Because our destination is always on the left. And so then, see my comment is actually wrong here. So let me go in and change that. This sixth line, I am incrementing B3. So it was 250. It's going to go up by a value of 1. And the value in register B3 will now be 251. So let me change my comment. Actually, my comment was okay. I see what I did. So I didn't use the word increment. I just noted it as I'm adding 1 to the contents of register 3. So that was fine. And then I'm going to end my program right there. So before I go ahead and step through, let me go up to a couple of these lines. So we can see here that when we're adding, it gives us a couple of pointers on the bottom left of the screen. It tells us when certain flags will be set. So the Z flag will be set if we add these and the result is 0, or the C flag for carry will be set if the result is greater than 255, which is the largest decimal number that we can represent with 1 byte. Well, we know that the result of this 250 and 10 will be 260. So we should expect to see the carry flag. And in your lab, I do ask you to look out for certain flags. So this is something to be aware of. Okay, so let's hop over to debug now. I'm going to click this little bug, and this will take me to a debug mode. So a couple things to note here in debug mode. No, I can't quite get to them. So let me switch over to registers. There we go. Okay, so you'll see we have a couple different tabs here. We can see what's going on in the RAM, the ROM, and then we have our registers. So this registers tab is what you want to bring up as you're stepping through your code. So right now our code is not playing, it is waiting for us to step through. So bring up this registers tab, and then over here where it says format, we can format these values right here. We can format those in hexadecimal, we can format them in binary, or we can format them in decimal just by clicking. So I'm going to format them in decimal so it's easy for us to follow along. And then I'm going to step through each line of my code. And so it doesn't display the results of a line until you're past it. So you'll notice we're on line 2 where we're putting the value 250 into register B1. So I have the B1 register over here, but it doesn't have a value in it yet because we haven't stepped past that line. We're on this line waiting for this command. So if I go ahead and step through, and this is really great because it highlights the changes in red for each line. So now that we've stepped through, we can see that the value of 250 is in register B1. So we're going to step through again, and you'll see we've switched that value, or rather we've copied that value over to register 3, just as it should be. We'll step through again, and we've put the value 10 into register 2. So we're just verifying each line of the code is doing what we want it to. And we haven't added or cleared anything, so our carry and 0 bits aren't flagged yet. Now, the really important thing to note here is that there is an overflow, right? We've hit 260. And so the register location B2 cannot fit all of this. The 260 exceeds the 255. So our carry bit is flagged. So in your lab, when I'm asking you when bits are being flagged, this is what I'm asking. Is at what point is a carry bit being flagged because it exceeds the value that a register can hold, or at what point is something zeroed out and the 0 bit is flagged. So just be aware of these flags as you step through your code. And we'll step through again, and we should see B3 incremented by 1, and that is the end. So we'll step through again, and that will be our code. So you can't really edit in the debugger. You'll see I'm trying to type things in and I can't. So if you need to go in and edit your code, there's an X on the top right here that you'll need to click, and that will take you back into editing mode. Now, a couple more things to note. One is if you look, you'll see these line numbers on the left side. I can't highlight them, but they're showing up 1 through 10. If you have an issue with your code, send me a screenshot and then reference these line numbers. So if you're having trouble with line 5, you just can't figure it out, you're getting a lot of errors, send me a screenshot or a snippet of your code and then tell me I'm having trouble with line 5. So these line numbers help to reference, of course, the different lines and make it easier to find what you're talking about, especially if you're writing really, really long codes, which we won't do in this course. But if this was your career possibly and you were programming in assembly, you would have codes that were hundreds of lines long or thousands of lines long, and so that's where line numbers get really important. Another thing I want to mention is that if you make a mistake with your command, so here I've accidentally, so to speak, put in a D instead of a V, it will say there's an unexpected token. So this is not the correct command. It's expecting a semicolon over it, or a colon, which would be a different command. So let me go back to V. Now if I put in, let's write our number the alternate way, remember? So with different assemblers, this is not hexadecimal, by the way, but if we put in 250 hexadecimal, it's saying there's an unknown command. We have our move command, we have our byte register, but it doesn't recognize what comes next. It doesn't recognize this number format. So that's a signal to us that we need to switch to a different format. Let's see what else we can do. Here you'll see let me redo that. It's suggesting commands. So IN is not a complete command. It's suggesting INC for increment or INV. So I can real quickly just correct that. And so the assembler kind of helps you out. If there's any errors, it will flag them. So see, it doesn't like this. I've removed that semicolon that was here in this comment on line 5. And so add was the first word that came after that, so it recognizes it as a command, but it doesn't recognize what else is coming up. It's not divided properly. So you can see we have add, there's 2 byte registers, but it's seeing all these things that it thinks are labels and delimiters, all of these notes, right, that it's not recognizing. So if you forgot a semicolon, it lets you know. Let's see if I delete one. We'll go on line 4. So this is not a command. The insert doesn't turn purple like add did because it's not a regular command. And so if I highlight again over this, it thinks it's part of that move command. See on line 4, we have move, our register, our number, and then it's saying register, number, and then it's getting confused. It's saying there's numbers, there's labels, delimiters, what's going on? And it's flagging that as being wrong. So that's your clue to go in and take a second look. So essentially you get an unlimited number of tries with these labs in a way. You can keep going through and changing them and perfecting them, and you can make sure they work. So you're not just writing out a program, submitting it to me and hoping it works. You can go through and debug this and step through, and you can confirm that the program is doing exactly what you want it to do. So this is just an overview of this assembler, an example program. This should be enough to give you an idea of how to use all these commands coupled with the lecture for this week. And you should be well equipped then to go through and do your lab 1.